Good evening, guys. Welcome to Unacademy. Welcome to my session. Welcome to Unacademy. Welcome to the networks class, guys. How are you all? I am Sankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country, expertised with the subjects of digital circuits and network analysis. Now we are here to discuss the network analysis. So daily we are meeting live from 5:30 to 6:30. Lock your time every day, guys. So we are in the part of AC analysis. Yesterday we came from transient state to steady state. Now we are going to discuss about the phasor representation or phasor diagrams using your steady state analysis, what we discussed in the last lecture. I'm fine, Deepak. Thank you for asking. I hope you are all doing well. Right. So if you are planning for an Academy Plus subscription, guys, sir, why to plan for an Academy Plus subscription, sir? See, in YouTube we are discussing, me and our total team are giving you the best possible content. Other than that, YouTube is having some disadvantages because it is not a dedicated learning app. An Academy is the dedicated learning app where if you take a Plus subscription, this is not for YouTube, this is for an Academy learning app. You will be having complete courses of your entire syllabus of the GATE and ESC in two languages. English it is completely there, Hindi it is there. All our team will teach you in both the languages, and you will be having regular doubt clearing sessions other than your general classes. Separate doubt sessions will be conducted. Weekly exams, monthly exams, subject wise exams, comprehensive exams, everything, topic wise exams. Unlimited practice is also free for you. After every class, you can download the PDF of the class immediately on your own. And also, we give the daily practice paper called DPP, and its solutions will be discussed in the doubt clearing session. And you will be having extra like rank improvement, crash course, revision, all batches, only one subscription. You need not take separate subscription for every single batch. Whatever we start, the new batches, new initiatives, everything under single roof. That is an Academy Plus subscription, guys. You can watch the classes live, and if you are working also, no problem. Generally our classes are in the morning and evening only. If you have some issue also, you can watch it recorded also, unlimited number of times. There are no restrictions from us, guys. So whether you are second year, third year, final year, or pass out, for every single student our academy will help you in n different ways. Even you are financially weak, you can go through the YouTube classes. If you are able to afford it, take the extra edge, guys. Definitely the amount you are paying for an Academy Plus subscription will be giving you multiple returns in the form of your subject, guys. You'll be enjoying the engineering in much more efficient way once you take the subscription, guys. So if you want to go for subscription, select GATE and ESC. इसके बाद क्या करना है? Get subscription. Then select the duration. It can be 1 month, 3 months, 6 months, 12 or 24. These are the best, most what we call economical subscriptions. I already told you fee is going to hike soon, maybe in this week itself. So to take the advantage of the lowest possible fee, take the subscription right now itself, guys. Before taking the subscription, please apply this coupon code Shankar 10, which will give you 10% extra discount, and you will be getting for this price. Other than this discount, you will be getting the best possible guidance from me and our total team. Please understand, this subscription is not for my single classes. This is for whole GATE and ESC. You can watch any class of GATE and ESC irrespective of no restrictions. This code is just for your discount and the what we call the respect you are showing in a different way. Once you, if you want to join an academy, as you love my teaching, you are entering into an academy. This is my referral code. You are entering an academy using my reference. Whether you or your friends, if anyone is taking, you can share my code, guys. Okay, so let's move. So if you plan for subscription, you can go for EMI of credit cards, HDFC debit or Bajaj EMI, according to your convenience. Then you can apply the code. Then you can proceed for the payment, whether it is a credit or debit or EMI or net banking, according to your convenience, guys. So this is our total October schedule. Every day I am saying this in the beginning of the video. Again, people are asking, sir, what are the classes going on? What is which batch may which class is going? What is this? What is that? Please don't ask individually. I cannot answer to thousands of students individually. Please come to the class on time and know about all our initiatives, guys. So this is the batch in Hindi, and this is the batch in English. These are our YouTube schedule for the October, which is completely free for you guys, right? So let's move. So day after tomorrow, Saturday, lock your time. Saturday, Sunday, we will be meeting from 9 to 11 for the crash course of digital electronics on YouTube. That is also free for you guys, right? चलो, कल क्लास में हमने डिस्कस किया. In the yesterday class we have discussed the transient and steady state conditions. Then steady state analysis we have done with a few problems. Now we are moving to phasor diagrams. Now we are moving to phasor diagrams. Before that, I have given you this homework for you. I remember that. Yes or no? Let's do this question and move to the phasor diagram. Okay? Is it clear? I don't think much problem. Nilesh, you can continue. Right? So let's see. Don't worry, Saket, we will use accordingly. Sometimes we do the experiments also. So what is the answer, guys? You have done this? Yeah, I forgot to say. Thank you, Pavanji. What is the speciality of today? It's half century, guys. Today is the 50th lecture. Yes. Let's clap for a moment. Yes, this is the 50th lecture, guys. Welcome to the 50th lecture. This is the half century, guys. I hope most of you have attended all the 50 lectures. I'm very happy to share 50 beautiful lectures with you, 50 knowledge sharing with you. I'm very happy for that, guys. This is the beauty of the education. I can share, I also develop, that is my knowledge will also improve, your knowledge will be also improved. So no one can take it from me, but I can give to n number of peoples. That will give us more and more satisfaction, guys. I want to say one more thing. This is education only can change the shape of you and your family and your well-being also, guys. So please take it as a challenge. Even you are financially backward or you have some issues also, fight, study well, do your education well, and bring your total family and total surroundings into a better position with your education, guys. That is possible. That is the power we are having with the education. Please keep this in your mind, guys. So prepare with all your energy, give your fullest possible effort. Thank you, Shivankar. Thank you all. Thank you, guys. Love you all. So let's start, guys. So what is the right answer here? Tell me what is your right answer. Tell me what is your right answer, guys. 100 sin 100t is my input. I have a resistor. This one is there, and you should tell me what is the right answer. कल क्लास में हमने किया 2.414 अभिषेक wrong answer. Yesterday class homework. Please tell me your answer, guys. Tell me your answer. Thank you all. Why 1.414, guys? Okay, no right answer. What is this? What is this, guys? Thank you, Nilesh. 0? No. Don't apply the bridge balance condition here. Minus j by plus j by minus j. Here the angle is minus 180 and here you will be getting plus 180. So for AC circuits you should be careful. Don't blindly apply the bridge balance concept here. Okay. So and also one important case, this is a specific case of minus j plus j is a short circuit and j and minus j is a short circuit conditions. Two short circuits in parallel. So be careful. Okay, let's continue. Who is that giving amperes? Sahil, the voltmeter reading is in volts, na? So determine the reading of the voltmeter. Ideal voltmeter should be replaced by open circuit because the internal impedance of ideal voltmeter is how much? Infinite. So replace it with an open circuit. Then what is the answer? Listen here. I will write this as 100 angle minus 90 degrees. You can take 100 0 also. I am taking cos as my reference. Then 0.5. This is minus j. And here you are having plus j. And this is j. And here minus j. Okay. Guys, be careful. Listen here. You take this current as I. What is the current I, sir? It is 100 upon zero point 0.5. I'm sorry, it will not be visible there. Just a minute, guys. What is the current I, sir? Because it is a 0, it is short circuit, it is short circuit. You can draw this figure. I'll draw it in the next page. Is it okay? See here. This is 100 angle minus 90 degrees. I didn't get any right answer from any one of the student today. The resistor is how much? 0.5. And here you can replace minus j and plus j with short circuit, plus j and minus j with short circuit, because 0 minus j, 0 kitna? How much it is? J minus j is 0. Okay, so you can say the current I is equal to 100 angle minus 90 degrees by 0.5. 200 angle minus 90 degrees. No need, Sankar, but you should remember it properly when you take it in the sign format. You should reconvert in the sign format. As a standard to avoid confusion, every time I'm taking it as a cos. Okay. Why shorted? Manikoteswarrao, please see here. Minus j plus j. You add these two. Minus 1 plus 1 is 0 na. J minus j is how much? 0. Ideal voltmeter should be replaced by open circuit. Okay. Chalo. Let's do the question now. 1 minute, guys. So if you take the input here, 100 angle minus 90 degrees, replace the voltmeter with a open circuit. Okay, so this is your network. Just go back in the capacitor. So I replace this with minus J1, minus J1. Okay, here you have an inductor J1. I'm sorry. If nothing is specified, we should assume it as an ideal. That is the common sense we should apply. Whenever examiner said nothing, we should assume it as a ideal. You cannot assume its resistance value, any value. So what is the best thing? We always assume it as a ideal. Okay, this is I. My dear friends, because both short circuits, you can take I by 2, I by 2. Nothing wrong. I by 2, I by 2 can be taken. Otherwise, take this as I1 and this one as I minus I1. I1, I minus I1. Apply loop equation. KVL. Negative to positive. I1 into J1. Positive to negative. Minus V positive to negative, minus I minus I1 into minus J1 equal to 0. It is a simple loop equation. So I1 J1 minus V, minus into minus plus I into J1. Now minus into minus plus, plus into minus minus I1 J1 equal to 0. So what is V? I times J1. What is I? Already we calculated I is 200 angle minus 90 degrees. So 200 angle minus 90 degrees. J1 means plus 90 degrees. So what is the answer you get? Okay. So what is the RMS value? Because the reading of the meter is always RMS value. He has also specified in the question, but in general also it is RMS value. Here please listen carefully. 100 is the time domain, mein 100 is maximum value. In the phasor you took maximum. So the answer should be treated as maximum only. So what is the RMS value? 200 by root 2. 141.2. Okay? Is it clear? RMS value is maximum value by root 2. Is it clear, Gajendra? Now it is fine. One minute, guys. 1 minute. Where is the chart? Okay, sorry. Okay. No problem, Abhishek. Let's go to the next topic. Now, yeah, we entered into the new topic, that is phasor diagrams. What are phasor diagrams? What is the use of phasor diagrams? Everything we will be discussing now. Right? So let's continue, guys. Okay. So short is Amritansh saying this whole is shorted, not individually shorted. Okay. If you take these two nodes are shorted, not this point or this point. Right. So let's go, guys, to the phasor part. Now listen here, very important point. I am giving you with the from very basic. So please concentrate for the next half an hour very carefully, guys. Listen. Phasor. What is phasor, sir? Phasor is the vector representation of sinusoidal signals. It can be a sine wave or a cos wave. Whatever the sine or cos wave you are having, for those signals, if you represent it in the with the help of vectors which rotates in anti-clockwise direction with respect to frequency. Okay, guys, listen here. Okay, already we have discussed sine omega t plus phi can be written as, or cos omega t plus phi can be written as magnitude angle phase. Yes or no? So if you take, please listen here. If you take this as your reference, okay. Now please listen here. What is 90 degrees? This one. I assume sine omega t is my signal, okay. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and again 360, and it repeats. So with respect to omega, your phasor is moving in which direction? Anti-clockwise direction. Okay. So I say, so for example, 2 angle 30 degrees. It is the magnitude of 2 angle kitna 30 degrees with respect to your reference. Okay. Please understand here, it does not give you the direction of the current. Please understand here, our direction is nothing but phase. Okay. If you say vector, vector means it has both magnitude and direction. Here what is that? We have magnitude and not originally direction. What we are having is relative phase. Relative phase with respect to the reference point. But we take the help of vectors to solve our network problems of sine and cosine inputs, because which makes our analysis easy. Whenever you need to add two sinusoidal signals or cosinusoidal signals or sine and cos signals together, it is difficult to add in the time domain. Suppose you have a sine omega t plus cos omega t plus phi, like that some signal is there. It is difficult to expand it, add it and do the mathematical part. Instead of that, we take the help of vectors by using our parallelogram law of vectors and whatever triangle law of vectors. By using them, we will be able to solve the problems easily. Ultimately, we are exploiting maths ka concepts jo hai na, vectors or whatever, and we are utilizing for our analysis purpose. Is it clear? Okay. So let's move. This is the basic. So phasor is a vector representation of sine or cosinusoidal signals. Please understand here the meaning of vector representation. Here magnitude and direction. Direction does not mean that current is moving in the direction. Direction ka meaning is the phase. Okay. What is phase? Relative phase shift you can say. So let's go. Right. So before going to this phasor, I want to give you the best possible way, the basics. I want to give very basics. I can say it is a very basic. You people may think, sir, why you discussing this also? That is required because I want every single student concept should be very clear. Okay. So please listen here. Please listen here. Resistor. In a resistor, in a resistor, you people knows it very well. What is the relation between voltage and current? V R equal to I into R. What is the phase difference between voltage and current here? Is there any phase angle between voltage and current in the resistor, guys? Is there any phase angle between voltage and current of the resistor, guys? Please comment, guys. Tell me. Manikoteswara, already I have discussed those things in the last lecture. I don't know whether you are present or not. These things we are analyzing is only for sine and cos as your inputs. Right, very good, very good, very good. So voltage and current ka angular difference kitna? Zero. So I can show, if you take this as your reference current, your voltage across the resistor is also, depending on the resistor value, it can be above or below, doesn't matter. See the direction, it should be in phase. In phase we represent in line, means there is no angular difference between them. No angular difference between them. Next, listen here. Now listen here. Inductor. If you take here one basic, you take it. XL equal to omega L, XC equal to 1 by omega C. Okay, you just take it for your understanding. Now, if you take inductor, voltage across the inductor is I into J omega L, or you can write it as I J XL, or you can write it as I XL angle 90 degrees. Okay, now listen here. If you take this as your current, with respect to current, the voltage will be at an angle of how much? Plus 90. Anti-clockwise may you take plus 90. Here you will be getting your V. So voltage is going ahead of current by 90 degrees. We call it as voltage leading current by 90 degrees technically, or current is lagging behind. It is behind voltage, lagging behind the voltage by 90 degrees. Okay. Sahil, if you open my notes, then you will get all the information. You can ask me, I will provide you the links, don't worry. Next, capacitor. Every time sending the notes, open that, you will get your required information. So please listen here. Next one, capacitor. For capacitor, what is the voltage across the capacitor is I into 1 upon j omega c. What is the meaning of it? I into 1 by omega c is xc, and you can write minus jxc. 1 by j is minus c. That is IXC angle minus 90 degrees. Now listen here. If you plot the same waveform for whatever we have done, if you take current as your reference, in the capacitor, voltage is at an angle of minus 90. Minus means in the clockwise you should go. This is how you will be getting. It is also 90 but in the reverse direction. Or here current is going ahead of voltage, that is current leads the voltage by 90 degrees. Here current lags the voltage by 90 degrees. Here voltage leads by 90. Here voltage lags by 90. So you can say like this. So I can say here voltage leads by 90. Here current leads by 90. But there is a chance of confusion. To avoid that, what we say is we every time speak about current. So if you speak about current, here you can say it is lagging. Current is lagging behind the voltage. If you speak here, current is leading. That is, you can say here current is lagging behind the voltage, here current is leading behind the voltage. But even I say like this also, still some students will have the confusion. Sir, I didn't understand this leading and lagging concept, sir. Will you explain me little more, sir? Definitely I can explain you guys. So I understand like this, but I'm not getting the clear picture about it, sir. What is the meaning of leading, sir? Yeah, is current is going first compared to voltage? Or current is going fast, sir, compared to voltage? Are they going in speed, sir? No. Please listen here. I will explain the meaning of lead and lag and what is that in phase. We call this as in phase, in line with each other. Okay, guys, now listen. Let me explain that concept. Okay. Suppose you take a simple sine wave. Okay, you have a sinusoidal waveform like this. Assume this is nothing but current in the resistor. This is the current in the resistor. Okay. According to the resistor voltage current relationship, V equal to IR. It may be more magnitude or less magnitude. R value is more, you may get more magnitude. R value is less, you may get less magnitude. Don't worry about the magnitude at this stage. Okay, don't worry about it. Now, how your resistor current will be means, it can be less or it can be more also. Don't worry. It is like this with a different magnitude. It can be equal also if R equal to 1. So it will be like this. It is always in phase. It will be moving with the same in phase with your current. That is, the voltage will move in phase with your current. That is the meaning of in phase. What is that? Both will have same phasor relation. The angular difference between them will be equal to 0, meaning kya? Both will be having. They need not start from origin. They may have some initial phase also, doesn't matter. Both should have same equal amount of phase. Suppose voltage is 2 angle cos omega t plus 30 degrees. Current should also be some value 5 cos omega t plus same 30 degrees. It can be 0 also. What I want to say, the difference of angle between them must be 0. The voltage current angular difference must be equal to 0. Okay. So is this point clear, everybody? Tell me. It can be attenuation, it can be amplification, doesn't matter. You need not concentrate on that. What is the point you need to concentrate is the meaning of in phase. Depends on R value, it can be more, it can be less, it can be in fact equal also. Is this point clear to every single student here? Shall I move further? Yes, guys, let's move. Let's move. Okay, very good. Now, let's go to the next part. Very good. So, suppose now what I am saying is inductor. Inductor may current lags the voltage. Okay, our current leads the voltage. What does it mean? Let us see. We are taking one current waveform is a sinusoidal input. It can be cos also, don't worry. Okay, so this is your current. Okay, compared to the current in the inductor, voltage is going ahead by how much? 90 degrees. What does it mean, sir? Voltage origin will start little early. Voltage origin will start little early. That is, this will happen in the background. So magnitude can be anything as I told you. It need not be equal also. So voltage, this will start little early and you will be getting a waveform like this. Just a minute, guys. Like this. Okay, this is how your voltage will be in the inductor. But it is looking a little confusing for me, sir. I'm not able to understand. Don't worry, leave it. I will give you another figure also. I will give you, forget about this. There is another way to understand it because my ultimate aim is every single student should understand. You take voltage as your reference. Here current is reference, so voltage is leading. That is its origin started little early than this. Okay. If you take current as reference, this is the plot you get. If you take voltage as reference, suppose this is your voltage in the inductor. So this is the voltage across the inductor. Okay. With respect to voltage, current lags by 90 degrees. 90 degrees means 1/4 of the time period. Please be careful, guys. Understand here. Current will start little late. Current will start little late. By how much time? 90 degrees. Okay. But what about this part, sir? Is the current is zero during this? No. The waveform ka trailing part will come here. Is it clear what I am saying? So this is the voltage and this is the current. This is what do you mean by lag? Current origin comes little late. It doesn't mean the current is zero here. Current ka negative part will come here. So current origin starts little late. That is the meaning of lag. In the time domain, you can say it is a time delay between the signals which will give you the lead and lag. It is the time delay between the signals which will provide you the lead and lag, you can say. It doesn't mean that it is zero during this period. Is it fine? Yes or no? Now you understand the meaning of the lag. Every time, see, suppose you want to add the vectors. Is it possible to draw these figures and add it? Will you add these magnitudes? It is very, you feel very discomfort to do this. if you want to add these two signals, suppose this kind of two signals are there, you want to add the magnitudes and all of those things. That's why it is always easy to represent like this. When this figure comes, iska meaning, you know it, this is the original meaning, which we are representing like this for our analysis, to make the analysis easy. To make the analysis easy, we are taking the help of this. Let's move. Let's move to the capacitor. So if you take a capacitor, current is going ahead of voltage, or voltage lags current by 90 degrees. Listen here. Okay. So assume this is your current in the capacitor. In the capacitor, voltage is lagging by 90 degrees, means voltage ka origin will come little late. Now you understand now? Right? Voltage ka origin will come little late compared to current. Like this. This is how your voltage will be in the capacitor. Or if you want, as I explained in the previous case, you can also draw by our another way also, by taking voltage as your reference also. Okay. So you can take any reference. So it doesn't make any difference. If you take, because it is a cyclic periodic signal, if you take this as your voltage signal, if you take this as your voltage signal, with respect to voltage, current leads. It doesn't mean that current will come before. Current will come before the voltage. Without voltage, there is no current. Please understand. Current ka origin will start little early. That is the assumption. Okay, current origin starts little early, and you will be getting something like this. Okay, so this is how your current I. Okay, with respect to the voltage, current will start little early. That is the meaning of current is leading. Or if the current origin comes little late, that is the meaning of current is lagging. Don't compare this origin and this origin. You should compare the same starting point of the cycle. Okay, if both are like this, it is called as in phase. We call this as in phase. Okay, voltage and current are in phase. Here lag, here lead. I hope you understand very clearly the meaning of the leading and lagging and in phase right now. Okay, so please understand that. Yes, 90 degrees lag means the same thing. You can see from here to here, if you go by clockwise, that is 90. That is the meaning of lag. Our voltage leads means anti-clockwise, it is going ahead by 90. So no confusion, guys. Is it clear, everybody? Shall I move further to the RLRC circuits? Is it clear? Tell me here why you people are not commenting. Okay, very good. Let's move. Right. Now we are moving to the next part, that is we have seen individually the inductor, capacitor and resistor. Now we are discussing RL, RC, RLC in series and parallel. Then we should see how it will help you to solve the problems easily. Okay, so let's move. Series RL circuit. So you have a phasor input V, right? Let us assume this is your current I. This is the voltage VR and this is the voltage VL. Okay. So now listen here. What is the voltage in the resistor, sir? Current I into the resistance R. What is the voltage across inductor, sir? Current I into J into XL. That is I XL. J का मतलब क्या? 90 degrees. Right. Now by KVL, can I apply KCL, KVL in the phasor domain? 100%. But don't apply for magnitudes. Magnitude and phase together you can apply. What is V, sir? It is VR plus VL. What is voltage V by KVL? VR plus VL. Now let's draw the phasor diagram of RL circuit. We did for R, we did for L, we did for LC. That is L, R, C individually. Now we are doing for R and L together. Listen here. Is it a series circuit or parallel circuit? It is a series circuit, sir. In the series circuit, what is common, sir? What is common in the series circuit? What is common in the series circuit? Okay. What is common in the series circuit? Current is common in the series circuit. Thank you, Koteswara. Current is common in the series circuit. So for drawing the phasor diagram, convenient way to start is take current as your reference. Take current as your reference. With respect to current, my voltage across resistor is in phase. That is, it may be something like this. With respect to current, my voltage across the resistor is in phase with the current. It is in line with the current. Sir, what about the voltage across inductor, sir? It is at a plus 90 degrees. It is at plus 90 degrees. It is at plus 90 degrees. Then what about V, sir? By vector analysis, you can say it is nothing but the magnitude of the VR. It is nothing but the magnitude of the VL. Then what is the magnitude of V, sir? By your parallelogram law of vectors and all, what is magnitude of the V? If you have this and this, the resultant vector will be like this. Resultant vector will be like this, right? This is your V and this is your angle between voltage and current. Which voltage and currents are? Source voltage and current. Okay, right. So by this figure, I hope you are very much expertised with the right angle triangles. So what is V by Pythagoras? What is your answer? Root of, tell me, VR square plus VL square. Sir, is it violating my KVL, sir? No. It is the biggest misconception. V is equal to VR plus VL only. It is not violating your KVL. Here what you got, it is only magnitude. 3 plus J4. What is the magnitude is? Root of 3 square plus 4 square, which is 5. That is, it is giving only magnitude, guys. Right. Now listen here. What is the phase here, sir? It is phi is the angle between the source voltage. Source voltage and current. Phi is the angle between the source voltage and source current. This is the voltage current phase angle. What is that? Tan inverse of, tell me, what is tan theta here? Opposite by adjacent, so tan inverse of VL upon VR. Okay, you can also write this as tan inverse of VL is what? You say VL is I into what is VL? Magnitude. I XL. What is the VR magnitude? I R. So what is the answer, sir? I can write this as tan inverse of I cancels XL by R. You can also write this as tan inverse of omega L by R. That is your phi. Phi equal to tan inverse omega L by R. Sir, phi is 90 degrees in inductor, 0 in resistor. If you R and L are together, what is phi, sir? Tan inverse omega L by R. It doesn't mean inductor voltage and current are in this phase. Inductor voltage current are 90 degrees only. Resistor voltage current are in phase only. But this voltage current is, this phase is for source voltage and current. Some people will have this doubt also. So some people will think in this case inductor will have this phase angle between voltage and current. No, inductor voltage current is always 90 degrees. Resistor always in phase. This angle is for what? Source voltage and current. Source voltage current ka phase difference. Okay, you can take anything, doesn't matter, Mahesh Babu. Finally, you should add the vectors. You add in your convenient way. Okay, whichever makes your analysis easy, we should go by that. That's all. Okay, right, right. Now listen here. Now listen here. One more thing. One more analysis. Here we define one more thing called PF. PF ka matlab power factor. Power factor is given by cos phi. We discuss at least half an hour of time for defining what is power factor and all those things in power calculation time. Okay. Why it is cos phi? Is it cos phi every time? All those things we discuss. For timing, for continuity, what is power factor is you just assume it as a cos phi. What is cos phi, sir, here? VR by V. Your VR by V can be written as I into R by I into Pura impedance. So you can also write this power factor as R by Z also. Every time, because you know cos plus phi and cos minus phi both are same or not. Cos phi is the same for positive angle and negative angle also. That is, even this voltage in the top or even the voltage in the bottom, both the cases my cos phi will give you same answer. So then how to understand whether it is RL circuit or RC circuit, sir? You should specify whether it is leading or lagging. Which one is leading or lagging? I should specify, sir. You should specify about current. You see, compared to voltage, source voltage, current is lagging behind. That's why it is called lagging power factor. For RL circuit, the power factor will be lagging. There may be confusion. You can say, sir, can I say voltage is leading power factor? No, as a standard, what we are following. If you take like that, there is a chance of confusion. To avoid that only, every time we are speaking about current. Current is lagging behind the voltage or not? Yes. So for RL circuit, the power factor will be lagging. Is it okay? So right. Next, one more point. One more point. Listen here. Your impedance angle is equal to angle of V by angle of I. That is voltage angle minus current angle, you can say. So voltage angle minus current angle will be positive for lag. Kyunki in that case current angle is relatively less compared to voltage angle. Okay. So current angle will be, or V angle will be positive, current angle 0, or it can be 30, it can be 10, it can be any values. The difference between them will be positive for lag, it will be negative for what? Lead. You can also take admittance angle as I by V. That doesn't matter, right? You can draw this vector diagram like this also, my dear friends. Listen. You can draw the same figure like this. What is this, sir? R, X and Z. Okay, is it clear? Rajshekhar, A plus JB. You should attend all classes, Rajshekhar, otherwise you cannot enjoy the class. Tan inverse B by A. Make A0 and calculate the angle, you will get the answer. Then you will get 90 degrees. These are the basic conversions which we discussed in the basic class. Please don't skip the classes as a habit. It will not fetch you the best results from me. Right? Okay. So, right. Is it clear? What is the angle of Z? Angle of voltage minus angle of current. In this case, phi is the angle between V and I. Na? That is what we call impedance angle. The angle between V and I, which is positive here, that is what we call impedance angle. It will be negative for leading condition, it will be positive for lagging. For example, voltage is like this, 2 angle 30 degrees. Current is 1 angle 10 degrees. What is the impedance ratio of these two? 1 angle is the difference of these two. How much? 20. Here current angle is less compared to voltage, na? That is what we call lag. Agar if you have 40 here, 30 minus 40 will give you minus 7, which is called leading condition. That is possible for capacitor circuits. Is it clear now, Pavanji? Shall we move further? Yes or no, guys? Tell me. You understand the basics of the RL circuit perfectly? Yes or no? Right? Power factor is equal to cos phi. Phi is the angle. Cosine of this angle will give you power factor. Power factor is the active power by total power. Those things we discuss when we discuss the power calculations topic, guys. So let's go. Okay. So let's move. Next condition we are going to discuss is RC circuit. Whatever the analysis I have done right now, the similar analysis or the same analysis is applicable for RC circuit also. So right, let's do it. Yes, Deepak, but basics are very important. Basics with clarity, with crystal clear clarity about every single thing is important. I need basics with very clear, very much clarity. So this is your current. What is VR, sir, here? I into R. What is VC in the RC circuit, sir? Minus J XC into I. That will give me IXC angle minus 90 degrees. If you apply KVL, what is your V, sir? VR plus VC. VR plus VC. Right. So story is repeated here. Take, I'm sorry. Take current as the reference. Current as your reference. With respect to current, resistor voltage is always in phase only. Resistor ka voltage is in phase. Okay. What about the current, sir? Resistor, sorry, current capacitor voltage, sir. Minus 90 means downward or upward? Downward. This is your VC. Now what about V, sir? Resultant addition of these two vectors. Resultant addition of these two vectors. This will give you your phi. You understand now? You observe the difference? Yes or no? So current is going ahead of voltage here. You see here current is lagging behind. Here it is leading. Right? So what is V here by Pythagoras, my dear friends? Root of VR square plus VC square. What is phi? Tan inverse of, What is that? VR, sorry, VC upon VR. That is tan inverse of, what is VC? IXC. That is XC by R. Like we have done in the previous case, it can be proved as tan inverse omega R, omega CR also. More clarity. I is common in both. Okay. So this is your phi. Then what is that power factor? Is equal to cos phi is equal to, what is cos phi here? Cos phi is equal to VR upon V. Right? Here you should specify, because you cos plus phi or minus phi doesn't make any difference in the value. So we should specify here what is that current is leading ahead of voltage. So this is the basic of RL and RC. Tomorrow we will discuss RLC circuits and all those things, guys. Okay, yeah. Tomorrow we discuss the series RLC, parallel RL, parallel RC, parallel RLC. Then we start the original problems. Very good set of problems. We are also having that. We will discuss everything, guys. Guys, everybody again and again asking me, sir, where can I get the notes of the previous classes? Uh, at least every day some people are asking. Please understand, guys, you stay up to the end of the video, you will understand every single thing. Don't ask me what is the schedule of this month, what is the crash course, what are the classes going on. You attend the classes, everything, every day we are saying the same things now. So please understand this. This is the Kreatryx gate. What is that? Our Telegram channel. Just every day after class I am sending the notes. By 10 or some night 10:30 or somewhere I am sending the notes, because I have other works, other class immediately after my work is done. Every day as a responsibility I am sending you the notes, guys. Just join group, go to files, you can see old notes also. Old notes is also available, guys. Okay, except two lectures, that is I think in basics one lecture, transient one lecture is missed because of some software issue. Remaining all lectures I sent the notes. Yes or no? You join this group also for regular getting your updates, right? Yes, Vishnu, right? We see, Nilesh, I don't know whether you attended every single class of me or not. First I discussed the theory, next I discussed only problems. So once the theory is completed, around 2 hours we do the problems. Every topic we do the same thing. Okay, guys, if you want to join Unacademy Plus, I have already explained all the benefits of it. Live classes, test series is free for you, structured schedule, unlimited practice. Extra thing is provided with iconic subscription. This is 25k fee for 1 year. This one is 45k for 1 year. If you take it, it is 30k for 2 years, and this is 60k for 2 years, guys. So you can use my coupon code. This is the coupon code to get 10% discount on all of them, whatever the courses available. In Iconic, what is the advantage? You have extra coach, personal coach, study planner will be given for you, digital coach will be provided, ENC mains and questions and answers, and expertise guidelines, personalized guidance for you. So you need extra care and all those things, you can go for Iconic subscription. So fees is going to hike every hour. Faculty is also informing you, guys. So to avoid the lately to pay high in the later, join the Unacademy right now itself. Even you are in the second year, third year also, you can join right now instead of joining next year with high fee. Join now. At the last 1 month or few months, you can extend it if required at the time of your exam, guys. So this is the coupon code. Please don't miss it. Shankar 10 is the code for your best possible guidance and the best possible classes. All the classes from me and our total team. You can attend any class irrespective of my code. I mean, you join with my code, but learn all classes, no restrictions. Okay, guys. Thank you very much. Shankar, good night. Kya you are sleeping? I have two more classes, Shankar. I cannot sleep right now. Okay, just kidding. So, guys, please do one more thing. One more favor is like and subscribe this channel. We have very huge amount of free initiatives. Your job is just to share these videos, share this information, share this channel to every single student who is studying engineering. Our ultimate aim is to teach to every single corner of the country. Every student should learn, whether it is free or paid, whatever may be the case, they should learn. So everybody as a responsibility, share this piece of information, share the video links, share the playlist, share the channel, ask them to like and subscribe. Whether so, this is my channel for Telugu students. This is the channel, you take it as your responsibility. All other channels, every channel is having its own expectancy. Okay guys, right. Thank you guys. Rajshekar, just draw sine and cos waveforms, you will understand. I attend my day before yesterday class. I have explained there already. Thank you guys.